Imagine a planet so distant and mysterious that its atmosphere is composed almost entirely of hot water vapor, a water world that challenges everything we know about exoplanets. Recently discovered by the keen eyes of the James Webb Space Telescope, this cosmic giant holds secrets that could reshape our understanding of the diversity of worlds in the universe. But what makes this discovery so unique? And why do astronomers believe it could be the key to unveiling new types of even more intriguing planets? The water world, the revolution in the search for aquatic exoplanets. Imagine a distant planet, so far that even our imagination struggles to capture it accurately. A true cosmic gem, where water vapor drifts in its atmosphere, creating a fascinating and mysterious environment. GJ 9827d, located 100 light-years away from Earth, has recently been investigated by scientists using the James Webb Space Telescope, JWST, and the results challenge much of what we thought we knew about exoplanets. This discovery is one of the most remarkable in modern astronomy, prompting astronomers and researchers to question: are we truly understanding the diversity of worlds in the universe? And what else might be hiding among the stars, waiting to be uncovered? GJ 9827d, a giant wrapped in water vapor. Since GJ 9827d was first identified in 2017, it has captivated scientists' attention. The planet is an exoplanet, meaning it orbits a star outside our solar system. It is located in what is known as the habitable zone of its star, a concept that has already piqued interest. After all, planets in this zone have the potential to host liquid water, something considered essential for life as we know it. However, as more data were gathered, especially with the powerful vision of the James Webb Telescope, it became clear that GJ 9827d was not a likely candidate for harboring life, at least not in terrestrial terms. Its environment is radically different from anything we've ever seen. Water vapor, a singular phenomenon. The most recent data, collected through a series of spectroscopic observations, revealed that GJ 9827d's atmosphere is predominantly composed of hot water vapor. This is not only intriguing but also unique. Astronomers had never observed such a large planet, enveloped almost entirely by water vapor before. This discovery has been met with great excitement within the scientific community, and it's easy to see why. Although water vapor has been detected on other exoplanets before, this is the first time that scientists have been able to characterize the atmospheric composition of a planet like this so precisely. As astronomer Eshan Raoul, co-author of the study analyzing the JWST data, noted, "It's the first time we've seen anything like this." Raoul's statement echoes the sense of novelty surrounding this discovery, a new window into unknown worlds. He added that while the planet is made almost entirely of hot water vapor, that doesn't mean it is a hospitable place for life. To be clear, this planet is not hospitable, at least not to the kinds of life we know on Earth, Raoul said. The high temperature of the vapor, combined with atmospheric pressure and other extreme factors, would likely render GJ 9827d completely uninhabitable for any life forms we are familiar with. The context of the discovery. But if this planet cannot support life, why is it so important? The answer lies in the rarity of what has been found. For years, astronomers have speculated about the existence of worlds entirely covered in vapor, but had no concrete evidence to validate those theories. GJ 9827d, therefore, comes as the first confirmation that vapor worlds are not just a hypothetical idea but a reality. The discovery story begins with the Hubble Space Telescope's mission. In 2024, even before the James Webb era, Hubble had captured hints of water vapor in the planet's atmosphere. However, those hints were just that, clues, fragments of information that weren't sufficient to conclusively affirm the atmosphere's composition. Now, with the help of JWST, that story has completely changed. The James Webb Telescope is capable of capturing data with an unprecedented level of detail, and it was this capability that allowed scientists to finally analyze GJ 9827d's atmosphere conclusively. The technique behind the discovery. The technique used to study the planet's atmosphere is called transmission spectroscopy, a powerful tool for exoplanet analysis. The principle behind it is elegantly simple. When the light from a star passes through a planet's atmosphere, the elements and molecules present there absorb specific wavelengths of light, leaving gaps in the observed spectrum. These gaps act like chemical fingerprints, allowing scientists to identify which elements are present in the planet's atmosphere. In the case of GJ9827d, transmission spectroscopy clearly revealed the presence of water vapor. Not only that, but the concentration of water vapor was so high that scientists now believe much of the planet's atmosphere is composed of this vapor. Comparing to other exoplanets. Until now, most exoplanets investigated had atmospheres dominated by hydrogen and helium, the two most abundant and lightweight elements in the universe. These planets, known as hot Jupiters or super-Earths, tend to be gaseous and immense, but their atmospheres are very different from what we find on Earth. However, GJ9827d stands out for an important reason. Its atmosphere contains heavier molecules, something more akin to what we see in the terrestrial planets of our solar system. The study leader, Caroline Pialet-Goreb, noted that this is a big step in the search for worlds that could, eventually, have environments suitable for life, even if not in the way we currently understand. The future implications. The discovery of a planet like GJ9827d, with an atmosphere dominated by water vapor, could be a game-changer for planetary science. While it itself doesn't seem capable of supporting life, its existence suggests there may be many other vapor worlds out there, some of which could have more temperate conditions and perhaps even harbor life forms we have yet to comprehend. This kind of research also broadens our understanding of how planets form and evolve. The discovery that there are planets with atmospheres so different from our expectations challenges science to expand its theories and seek new ways of interpreting data. With advancing technology and the growing capabilities of telescopes like James Webb, it's possible that in the coming years, more similar discoveries will emerge. Each new planet we find offers a new piece of the cosmic puzzle, and eventually, these pieces may form a more complete picture of how the universe truly works. A revolution in astronomy. For Eshan Raoul, the discovery of GJ9827d was a personally significant moment. It was a very surreal moment, he said. As an undergraduate student at the time the data were collected, Raoul was able to see firsthand how advances in observational technology are transforming astronomy. Working with the data from the most powerful telescope ever built at this point in my career shows that there's never been a better time for young people to get involved in astronomy. Raoul's words echo a sentiment spreading throughout the scientific community. We are living in a new era of astronomy. With the help of tools like JWST, scientists are now more equipped than ever to explore the mysteries of the cosmos. Conclusion. GJ9827d is much more than just a distant exoplanet. It represents a new frontier in the study of water worlds, proving that planets shrouded in water vapor are not just a theoretical possibility, but an observable reality. While it is not habitable in the way we understand, this discovery offers a glimpse into the complexities we have yet to fully grasp about the universe and its myriad possibilities. As we continue to explore, who knows how many other planets like GJ9827d are waiting to be found.